Hello, ladies and gentlemen. What's up? It's Papa Bale. Welcome to the channel. Please like, subscribe, and hit the notification bell if you'd like to see what's coming up in the future or in the past. I got lots of cool stuff. All right, so what we're going to do, what we're looking at is a 120 degree SSG with nothing on the output currently. But I'm thinking about hooking up like a 100-watt light bulb to be the load. Anyway, we're gonna start off with no load at 9 volts. All right. Hit the switch here, little toggle switch. Ooh, that is high pitched. That is so cool. So I have you got these transistors over here, right? And then I have a bunch of these ones, which happen to work with it, just not as well. They end up going pretty quick with like 20 volts going through them, but you know. All right, so how this is hooked up, the positive end of this first coil goes into the positive end where the coil goes, and then it goes around, and there's a rectifier diode in between each coil, and it ends up right here at the ground for the coil slot. All right. So the trigger coil is right next to it. So you got 4 wires there. 1, 2, 3, 4, the fat ones. And then you got your power input connected to the switch and the power supply. See, we're not even at 100 milliamps. Look at that. Look at that speed. It's 9 volts though. Yeah, definitely a 9-volt battery. So yeah, and I do quizzes or like kind of trivial pursuit type things on my community channel every once in a while. And when I ask about magnets on the rotor, I'm talking about a radial disc. I'm not talking about a Newman motor with just a magnet in the middle there. That's not what I'm talking about. Obviously, the Newman motor magnet is going to be going really, really fast, and that's just not what I'm talking about. I mean, yay for Newman motor, but no. I'm talking more like this right here. Yeah, but it just doesn't qualify, if you get what I mean. So yeah, I am planning on building a Newman motor in the near future. Well, maybe not near future, but definitely one in the future. And I'm going to make that probably with 20 gauge wire. I was even thinking about building maybe one with Litz wire. I know that's crazy, right? I mean, how would you make one that long that would make a good Newman motor? And I'm thinking it could be a lot shorter if it's Litz wire, especially if it's 20 gauge Litz wire. That would be dope. Anyway, we are at 9 volts. That is pretty good speed for 9 volts in a mid-grade transistor. Let's do 12. Let that sink in. We are drawing 100 milliamps currently at 12.5 volts. It's below 100 now. Look at that speed. Look at that phenomenal speed for what's going on here. That's 12 volts. That's a pretty fast 12 volts, I think, for not having an amp draw currently. And that having the other two coils has reduced the amp draw and increased the speed. Phenomenal. And a downgrade in the transistor. So I mean, that's a win-win-win right there. That's rare. The triple win, that's awesome, and it's rare. But we just did that right here. I'm gonna get my tack meter. I'm gonna find it. There it is. Somebody already saw it. Good job. All right, let's see. Look at that. That design on there is pretty wicked, isn't it? 888. $889. All right, I think we've reached kind of the peak of 12 volts with this system. It's not 1,000 RPMs yet, but we are drawing less than 2 watts. $15 volts. Drawing 1.5 watts. And the pole's starting to shake, so I guess we're going to lose a little bit of speed due to friction. But then at the same time, we're going to gain speed due to voltage. And we are drawing 100 milliamps now, so we're increasing current. $10.72. You know, I think we managed to get it down on the table. Just get all the coils down on the table, get the rotor down to the table. Having that lower center of gravity will allow it to move faster. And we've got a magnet underneath there that's attracting the rotor. So that magnet down there on the bottom is sucking the rotor down to the flange that it's resting on, causing more friction. But it's stabilizing it, I think. 11.105. No, I'm just kidding. 1,105. All right, but I've had this thing blazing at like 20 volts, so we're gonna up it again. Now I'm drawing 200 milliamps. 20 volts. $200 milliamps. 13, 14, 13, 20. Wow, that's pretty awesome. I think it would definitely be going faster if we could hold it still. I think it would be a lot more still if it was down on the ground. So I'm going to fix that for our next run. I'm going to cut the power. Oh, that's awesome. All right, thank you very much. Peace out. Have a good day. Please subscribe. Bye now.